Okay, well, I guess we can get started here. It seems there's only one bit of feedback in the comments about how things went during week number 3, but you can feel free to add something there still while we're getting started. And yeah, we'll continue this week talking about functions, so that'll be our main topic for today, but we'll also talk about a few other things, including the use of large language models for generating code, which will have a little bit of a demonstration about how that works and give you a sense of how you can use things like ChatGPT to write Python code after the break, most likely this morning. So regarding the feedback first here, there's a question about, is it a problem I didn't use the command and in exercise number 3? I guess this must have been, I don't recall which problem. But I don't necessarily think you had to use the and command in order to do things. So we had 3 problems. Basically, there was the batch processing problem where you were generating a list of file names. You don't need the and or logical and for that. Classifying temperatures, you can use it, but you don't necessarily have to use it to classify temperatures. In that case, you might remember that we were trying to find temperatures that were within a range of values here, such that cold was less than -2 degrees, slippery was equal to or warmer than -2, but less than +2. So there you could use and, but you don't necessarily have to. So perhaps that's the place where you might be wondering whether you needed to use the and operator. And then for allocating locations, again here, you don't necessarily need to use the logical and either, because essentially you can just have a set of tests where you first can determine which, like, are you north or south of some reference point, and then east or west of some reference point. So in that case, there's no, it's not necessarily required for you to have used the and operator. So yes, if you didn't use that in exercise 3, I think you wouldn't necessarily be that you've done anything wrong. And good to have the feedback here that the pair programming worked out nicely. Always happy to hear that. And then there was a question about the difference between using if, else, and if, elif, else. And yeah, we could go through a quick example of that. Probably need to open up a Noppe session, I guess. And so quickly, if my password manager thing wants to play, I'll log in here and open Geo-Python 2024 session. And yeah, we can just do a quick demonstration of how to use, or how this sort of logic differs between if, else, and if, elif, else. So let's see. So I'm just going to open a notebook here. You don't have to necessarily do any of this, but we could say, for instance, temperature equals 10 degrees, which is maybe roughly what it was this morning. And we could then have a set of tests where we check to see if the temperature is, for instance, cold, cool, and warm. So we could say, for instance, if temperature is, let's say, less than or equal to, let's just say 10 degrees for the sake of demonstration here. So if temperature is less than or equal to 10 degrees, we can print that temperature is cold. So I think the logic here is probably fairly clear, and we could have, for instance, an else statement here that will catch the case that the temperature is not less than or equal to 10 degrees. So if this is false, then we would get the print. And I'll just copy paste this to save a little bit of time. That temperature is not cold. And of course, when we run this, like we saw last week, we see that this first test is true because the temperature is less than or equal to 10 degrees. We defined it to be 10 there. And it says 10 degrees is cold. Now, of course, that's all relative. But the question was, what about the difference between if, else, and if, else? So we need a third condition in here. So in order for an else condition to work, you have to have an if before it, but we can make another if statement here that says if temperature is less than or equal to 15 degrees. Then I'll just paste our same little text from before to say that the temperature is cool. So it's not quite cold. I don't really think 10 degrees is necessarily cold either, but whatever. So what should happen here is that in this first case, we'll do the test. Is temperature less than or equal to 10 degrees? If so, we print out the temperature is cold. Then when we come to this second if statement, it's completely independent of what's happened in the previous one. So even if the temperature wasn't cold, this if statement will get checked to see whether temperature is cool. And then the else statement would happen if the temperature was not cool. So when we run this, we get two things printed out. We get that 10 degrees is cold and 10 degrees is cool, because both of these tests are run. And anytime you have an if statement, it basically will not care about any preceding if statement above it. Now, if we just copy this cell, which I'll, let's see, copy cell, paste cell below. We just duplicate that cell that we had there, and let's make one change. Let's make this now elif. What's going to happen in this case is we're going to run the first if test. If the condition's true, we'll get this print statement, and everything else, the elif and the else, will get skipped. Because once you pass and meet one of the conditions in a set like this, it will ignore the remaining tests. So the difference from above is that this was an if statement instead of an elif. In order for an elif to work, it has to have this case where it's already failed some previous if statement above, and now it's checking another condition. So, okay, well, if this wasn't the case, then what about this one? And that's what happens here, is we check and see if the temperature less than 10 degrees, print temperature is cold. If that's not the case, let's check another condition. Is it less than 15 degrees? If that's true, then it will print that statement. If not, it will then proceed to the else statement at the bottom. So when we run this one, we only get one thing printed out to the screen. And that's because this doesn't get checked because the first test was true. Just to maybe further demonstrate this, let's change the temperature. And actually, I should probably have done this in a smart way to begin with, and that is to put temperature in its own cell. And let's make the temperature be 12 degrees, and let's just delete the temperature here and delete the temperature there. So if we change it in one place, we'll just run our two cases here. So we redefine temperature to be 12 degrees now. We come here to the first test. Is the temperature less than or equal to 10 degrees? No. So this won't get printed. Then we come to the second test. Is the temperature less than 15 degrees? Yes, it is. And then it will print temperature is cool. In the second case, basically the same thing will happen more or less, but the difference here is that It's just a sort of, the second condition depends upon having failed the first test. So we should get the same output in both cases, that 12 degrees is cool. So the difference here really matters if the temperature is less than 10. If we put in a temperature of 8, we get two things printed out here because this second if is independent from what happened the first test. I don't know if that clarifies the sort of difference between the if, else combination, but essentially these are chained together. When you have an elif, it depends on what happened here. When you have an if statement without the sort of L part, it's like starting a new chain that doesn't care whether the temperature, like what happened here doesn't matter. This test gets run every single time because an if statement the first time will always get executed. Does that make sense? Generally? Yeah, okay. Good question though, and yeah, happy to sort of demonstrate those things. And very nice, someone noted something here about the grader bot. Yes, so I had a couple things I wanted to remind you of this morning before we got into the lesson materials, and one of them actually does directly relate to this. And the question is almost exactly the point I wanted to make. So I noticed the grader bot graded exercise 2 and I received rather poor points. I had quite many issues in the end, managed to do the homework. There's no feedback yet. Are the points reviewed by teachers, and are those the final points now? So some of you may have noticed you have an exercise number 2 that looks like this, that may have a last commit message, for instance here, that says grader bot added points to exercise 2. If you scroll down, you'll also see, for instance here, this little block of text added to the end of your README file that says exercise 2 grade and feedback, and it has some number out of 10 points. I will tell you, if the grader bot graded this, it cannot be more than 8 points right now. And it says the grader was grader bot awaiting review by a course grader. So yes, how this works is that we run this grader bot to automatically grade the parts of the exercise that can be automatically graded, but it's not infallible. It can make mistakes. There are some cases where you've done something right, but the grader bot sees it as an incorrect response. It could be, something kind of rather silly with the formatting. It could be a list that has one too many items or something like that. And it trips up the grader bot and it says you didn't get the points for the problem even though you did everything correctly. That is why, after the grader bot has been run, we then give the green light to the course assistants to go through and review the exercises and assign the final points. So if you see this and you're worried that you didn't get that many points, until you have one of the course assistants' names here as the grader, this hasn't been reviewed and the points are not final then. There are some problems, for instance, in this exercise, problem number 3, where we can't auto-grade your responses because we ask you to make a markdown cell and add an image, and we don't have a way to automatically grade whether you've done that. So those points would never be given by the grader bot. They have to be assigned by the course assistant. So if you have any questions, once your course assistant name is listed here as the grader, you can always ask them either, probably it's best if you can send them a message directly in Discord to ask, but you can get information from them about how things went, what went wrong, and if you feel like, oh, maybe I think I did this right and you didn't give me the full points for it, you can check and see, for an explanation about why you did or did not get the points you expected to get. Oftentimes you'll also get a little bit of feedback here. We tell the course assistants to give a little, couple sentences short feedback, but if you want more feedback on the exercise, you can also contact them directly and ask for additional feedback. I think they're generally happy to do that, but in order to save their time doing the grading, we ask them not to give exhaustive feedback for every person's exercise because can easily become quite a big time sink. Not that it's not worthwhile, but it's just, it can become quite time consuming, especially for people who are learning to grade the exercises and things like that. So anyway, point here is that if it says it's graded by the grader bot, that's not the final points on the exercise, and it will get reviewed by a course assistant. And once that happens, which we try to ask them to do that within, roughly 4 to 5 days after the grader bot has been run, you'll see their name here. And if you have questions about the exercise at that point, you can contact the course assistant. Hopefully that clarifies the question about the grades here. Just check. Okay. Nothing else there. Couple other things I wanted to just note. Some of you have perhaps noticed on the exercise problems, there is this little AI tool usage agreement thing here. I realized that we never actually said anything about this in looking through the exercises, or at least I don't recall having said anything about it earlier. And that was a sort of oversight, I think, on our part. But you are expected in doing each problem in the exercise to enter your name and the name of your partner into this cell if you're working in a programming pair, to indicate that you will follow the guidelines on the use of AI and large language models in the course. And so there is, on the course page, a description about the acceptable use of things like large language models for generating code. And generally speaking, we are open to the idea of using them, but only in cases where it's labeled like this AI LLM OK, which is a terribly awkward thing to write. But what it means is that you're okay to use a large language model for generating code for that part of the exercise. If this statement is not there, we'll see in this week's exercise an example where it is, then basically you shouldn't be using things like ChatGPT to generate code. There's benefits to using language models to write code, but you also have to understand the code that it generates well enough to know when it writes incorrect things. And it's not that hard to get decent looking code that actually doesn't do what you're thinking it does from things like ChatGPT. So with that in mind, we ask you just to be sure on every problem to put your and your partner's names here and the markdown cell at the start of the exercise, just to indicate that you follow the usage agreement we have on the course page. And if you want, you can read through this in more detail, but essentially we follow the guidelines of the university as far as the use of AI and large language models go. And the main thing to be aware of is that if you are using things like ChatGPT to generate your code and you're not supposed to, and you don't tell us about that, it is considered cheating. So there can be repercussions for that. I don't think we've had any cases where we've had to do anything other than maybe raise a question about this sort of source of code that someone has generated. But there can be pretty serious repercussions if you're using things like ChatGPT without disclosing it. So you can find links to the university's guidelines on the use of AI in teaching and learning from this page about the use of AI tools on the course page. I guess, Kamyar, did you go over that like in the first class? Yeah, okay. So the main thing is that a few of the course assistants have noticed that not everybody's been putting their names in here. So please do add your name to the exercises when you complete them. I thought I had one other thing in mind. There was a question from somebody on Discord, and I just wanted to highlight this about copying and pasting cells in the notebooks. It's completely fine if you've written code into one cell to copy and paste that code into another cell. There's no problem with that at all. It's not like considered cheating. It's not going to do anything bad in terms of it won't break anything in the notebooks or whatever. But if you copy the cells, so I showed like this example of going and just taking a cell and doing this edit, copy cell, edit, paste cell above or below. If you copy the cells in the exercise notebooks, it will break the autograder. So please don't do that. It's not an unfixable thing, but you'll see if you've done that I have to go into your notebook and fix things in order to get the autograder to work. So it's mostly just kind of a hassle for us, and it's better, like it's completely fine for you to add a cell if you need to. You can just click the plus button to add a cell, but please don't copy paste the cells. If you need to copy paste content, you can add a cell and then select what you have here and then paste it into the new cell. That's completely fine. But yeah, copying and pasting the cells themselves, it just does bad things for the autograder. So yeah, we'd appreciate if you don't do that. Okay, are there any other questions about week 3? So we have used a little bit of time already, but I feel like I would be remiss if I didn't show you how to do this problem number 4 from exercise 3 about generating this little flag type pattern. Because, well, it's kind of interesting. There's several different ways you can do it. And the key thing here is just to recognize that with a few for loops and a few conditional statements, we can basically generate this flag relatively easily. And the key thing here is to recognize that there is some regularity to the pattern of characters that are making up the flag. So there's 7 stars here, and then I don't know how many dashes. Is it 12? Something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so 7 stars, 12 dashes, which means there's 19 characters on this line. So the lines that don't have any stars will just be 19 dashes. And like I said, there's a few different ways you can do it. The idea is that you want to generate a character string that you can then print out to the screen that makes this flag pattern appear. So if we start, for instance, I'll just put it down here in the cell since I've already got this notebook open, with the idea that we're going to need one for loop to allow us to go over each row, and then one to go to each position in the row. So we have 5 rows in our flag pattern. So we could say, for instance, for, let's say, I in range 5. That will allow us to go to each row of our flag. And then we have a second one for j in range. And this should be now the number of characters along the line of the flag, which is 19. If we did this just as it was, we could, for instance, just make a thing of all stars. Oops. I think I need to maybe do something a little bit different here because I've just made a whole bunch of stars in a vertical row. Maybe I don't want to print this. Let's make our flag empty to start. So it's an empty character string. And when we come in here, we could, for instance, just say that flag equals flag plus a star. We'll just make a whole pattern of stars to begin with. And so this will happen in the first time through this loop. I will be equal to 0. We'll go in here, and then that'll be our first row of our flag, and we'll go 19 spaces across, adding a star. And when we get to the end of that, or here, after we've added our 19 characters, we need to add one special character there to break the line to indicate that we want to start the next row. And so here we can say flag equals flag plus, and then this is a weird one, this new line character, which will indicate that that's the end of the line. It will then add this line break and then continue on to do the next iteration. So go to row 2, write 19 stars. Go to row 3, write 19 stars. So that's now our flag, and I'll just add down here a print statement to print it out so we can see what we've generated. So we made a little block of 19 stars. That's part of what we need to do, but not the whole challenge. What we need to do at this point is we need to consider that if we're in the first 3 rows of our flag, we want a little bit different looking thing, and in fact, it'd be better if we just made the flag print out these dashes instead, because it's mostly these kind of hyphen characters, and the star is kind of an exceptional thing. So in order for this to work, we can add a conditional statement in here that says if I is less than or equal to, well, let's say if it's less than 2, less than 3. Let's do it like that. So that means we're in row 0, 1, or 2. It's the first 3 rows of our flag. We're going to say that our flag pattern will look a little bit different. We'll just leave this with something kind of as a placeholder for now. That we know we need to do something different there because we need to have stars first and then these dash or hyphen characters. But otherwise, if we're not in the first 3 rows, then we just want our flag equals flag plus this dash character. So that'll work for the last 2 rows because that's what our flag needs to look like. In here, in the first 2 rows, we need to have an additional test. So we check to see, okay, are we in row 1, 2, or 3? But then we need to check and see if J is less than, and here we can say less than, I guess it would be less than 7. Because if that's the case, then we want our flag to be equal to flag plus the star character, because we're in the first 7 character positions in this row of the flag. And again, here, if that's not the case, if we're not in the first 7 characters, then we say our flag equals flag plus the dash. There's several ways you can do this that would be maybe even simpler than this. Here we have 2 for loops and several if statements. Logically, this might look a little bit messy, but if we run it, what you'll see is you get the 7 stars and the 12 hyphen characters, and I think that should look more or less like what we're supposed to get. I don't know if I can copy paste this thing and get it to look nice in here, but let's just make that a raw cell. Looks like it worked. Don't worry if this logic is a little bit confusing here. Essentially, we have to have these 2 loops to allow us to go to every position of our flag. We have to have this check to see, okay, the first 3 rows are different than the others. Let's see if we're in the first 3 rows. And then we have to have this case of saying, okay, well, if we are in the first 7 characters of the first 3 rows, then we should have this star character, and otherwise we want a dash there to get the first 3 rows of the flag to work properly. You could do this in a simpler way as well with a single for loop, because it's not really that complex of a pattern. We could, for instance, start with our blank flag thing and just say for I in range 5, if I is less than 3, flag equals flag plus, and then we can use some fun stuff here, which is 7 times the star character plus 12 times the dash character, because you can multiply things in a character string to make them show up multiple times, and then we can just go ahead and add our new line character here as well. And I'll just copy paste this else. Something is not making this happy. Else, this is going to be, let's just delete that one, 19 times the star character and a new line. And if we print our flag like that, okay, for, I guess I need a letter I here, we can get our flag with just a simple for loop and 2 conditional statements as well. You could probably even make it simpler than that, because you could basically say, make a line that says like star line and a line that says dash line, and just do 3 times that plus 2 times the other one without a for loop at all. But the point here was to have you use these nested for loops, as it's a common approach when you have things where there's X and Y positions, for example, latitude and longitude. You're often needing for loops that are nested to be able to access those points. Okay, I've wasted enough time, I think, so far with this, and we should move on to today's lesson materials. But are there any questions before we proceed? All right. So going back into our My Work folder here, if you're in the CSC Noppe, and into the Notebooks directory, first step, as usual, is going to be to go to the Git plugin and click the little pull latest changes button, the cloud with the down arrow, to get our lesson number 4 notebooks. If you have any trouble with that, let us know. Kamyar can come and give you some assistance. But this will give us our notebooks for lesson number 4. So when you go back into the file browser, you should see now that we have this L4 directory. And we're going to start with our notebook on functions as the first thing that we will cover for the lesson today. So our lesson topic is about functions, and you might be wondering, first off, what is a function? Well, in terms of computer programming, a function is essentially a block of organized and reusable code that can help us to make repetitive things in the code easier to use without having to type them in every single time. So, for instance, instead of having to type in an equation to convert temperatures from Fahrenheit to Celsius every time you need to do that, you can create a function that does that. You define the function one time, and then you use it. And we've already been using functions. We've probably mentioned the name function several times, but for instance, the print function is a built-in function in Python that allows you to print things out to the screen. I think in the first lesson, we maybe even used a little bit of some of the functions from the math library, like math.sine or math.square root, to calculate things. But we haven't yet created our own functions, and this is one of the things that can help expand what you can do in your programs, and it's quite useful topic for addressing a kind of common good programming practice, which is to not repeat yourself. Like, you shouldn't have copied and pasted blocks of code. Normally, if that's the case in some notebook, you've got the same code several times over, probably you could define a function to replace that code. And that way, if you need to change the way that that little piece of code operates, you change it in one place instead of having to change it in multiple places, or forgetting to change it in some places, which can lead to problems. But yeah, we can start out by making our first function here, and we're going to make one to convert temperatures from Celsius to Fahrenheit. And we can start our function with a def statement, which indicates we're defining a function. Then we can give the function name, which is, in this case, Celsius to far, to avoid having to type out Fahrenheit. Then we have some parentheses, and inside here we're going to put one variable name, which we'll call temp in this case. And then we end our def statement with this colon character. And if you hit enter, you should see that automatically the code underneath the def statement gets indented. It's just like a for loop or a conditional statement that things that are part of this function definition will be indented within there. Then we have a return statement. And this is going to indicate when we use the function, what's the value that you get back from it. And here we could say that we'll return 9 divided by 5 times temp plus 32. So this is the equation to convert temperature from Celsius to Fahrenheit that we have seen earlier in some of the exercises and lessons that we've covered so far. So when you run this, you should see that there's no output, but we've now defined a function in memory that we can use, and we'll test that out in just a second. But just as a reminder here, when you look at this, our sort of anatomy of the function is that we have this def keyword to indicate we're defining a function, some name that we give it. This can be any valid Python name, so as long as it doesn't conflict with things that are kind of reserved names like if or else, we can put in some name here. It's just like variables, so it has to be a valid name. Then inside the parentheses of our function definition is a parameter. You don't necessarily even need to have a single parameter, but very often you'll have one or more parameters that are listed here. And then the colon to indicate the end of the definition. And then you can have several lines of indented stuff underneath there that do things, but typically you'll then have a return statement that says, okay, when the function's used, what value do you get back? So let's take a look at how this works. And I think our first natural case here is just to test out converting a temperature and printing it out to the screen. So let's do that. And we can start here by saying, for instance, freezing point. We'll get the temperature of water freezing in Fahrenheit from our function by saying freezing point equals Celsius to var with a temperature of 0 Celsius. So this should give us a temperature in Fahrenheit, degrees Fahrenheit, at which water freezes. When we run this, we don't get any output, again, because we're defining a variable here, but if we had a print statement to say, for instance, water freezes at, and we could say freezing point, degrees Fahrenheit. Again, you don't have to type all of this in exactly, but some kind of print statement like this, where we put our freezing point variable inside of an F string. And we run this, you see water freezes at 32 degrees Fahrenheit. Okay, for those who are familiar with that temperature system, you'll recognize that that is the temperature at which water freezes in Fahrenheit. And we could also do the same thing with the boiling point of water. So if we set 100 degrees Celsius in our function, we can print that out. And we don't even need to define a variable to do this. We could simply say print, and we'll make another F string, that water boils at. And instead of putting a variable name in here, we can actually put a call of our function inside the little curly braces here and say Celsius to var and 100 degrees. And then we'll say degrees F, because I don't want to type out Fahrenheit. So same basic idea as what we just did above, but just noticing that we can also put in a call to a function inside the curly braces here. Anything that is a value that we want to have displayed in the F string that is going to come from some kind of variable or calculation can be put inside here. So this is also perfectly fine. And we see that water boils at 212 degrees Fahrenheit, which is also, looks like that's correct. So we've defined now our function for converting temperatures, and we can see quite easily how this works. We could also, just in modifying what we did here, when you pass a value inside of a function call, you can also give the variable name. So we could say, for instance, temp equals 100, because temp is the parameter that we have defined in our function. So you can give it without, or you can give with the temp equals like this. And in our case, you'll get the same output either way. But oftentimes, especially we'll see some examples where there's more than one of these parameters that you have in a function. Once you start having more than one, it can be useful to have the name in here just to make sure that you know which value is given to which parameter. So let's try it out again. Let's make another function. This time we can make one called kelvins to Celsius. And again, since we're making a function, we'll start with our def statement. I'm going to give it the name kelvins to Celsius, like that. And we'll give it inside here temp underscore kelvins as the name of the parameter the function takes. And then add the colon character at the end. And in this case, what we expect to get back for our return statement is the temp in kelvins minus 273.15 degrees. So that's our conversion factor from kelvins to Celsius. So like we did before, we could, for instance, define a variable here called absolute zero. And we'll say that that's if we do kelvins to Celsius of 0 kelvins, that's absolute zero. And we can run, first run our cell to define the function, run this to store the value of absolute zero, and then we can print it out to the screen like we did before using an F string. So we could say, for instance, absolute zero in or is absolute zero degrees Celsius. So our kelvins to Celsius function should convert the value of 0 kelvins to some number of degrees Celsius, and then we're just going to print that out to the screen here with our F string and see that absolute zero is minus 273.15 Celsius. Not a big surprise here because 0 minus 273.15 is minus 273.15. So looks like our function works. We could put in some different numbers there to test it out further, which would be a good idea, but I hope that you can trust that this function looks to be working properly and as expected. So with that in mind, we can have a look at a question for you to test out making your own function using an obsolete temperature scale developed by Isaac Newton that is kind of a precursor to the modern day Celsius scale. So in this case, water would freeze at 0 degrees Newton, boil at 33 degrees Newton, and at least when I've did some very quick surveying of information about this, it's not clear whether the sort of temperatures go linearly between 0 and 33 degrees, but let's assume that they do. Meaning that we can have a very simple conversion factor to map things from Celsius to degrees Newton simply by multiplying by 0.33. Because we know water freezes at 0 degrees Celsius, boils at 100 degrees Celsius. So if we multiply by 0.33, that should allow us to convert to newtons. So your task is to make a function called Celsius to Newton that has one parameter, which is the temperature in degrees Celsius, and returns the value of the converted temperature in degrees Newton. And you can use the cell down here to do that. And why don't you take a moment and do that, and we'll proceed with the lesson after that. All right, so if you're still working, I apologize. You can try to ignore me for a moment here, but otherwise we'll move forward and just show you an example solution here. So the idea is we wanted to create a function called Celsius to Newton. So of course we can start with a def statement here and our function name, which is Celsius to Newton. And we'll have a single parameter in here called temp Celsius. Just to be clear that we're working with temperatures in Celsius inside the function. Never hurts to kind of clarify that type of thing. So that's our function definition. You can see the function name and the parameter it's going to use. And then for our return statement, we're simply going to return the value of temp Celsius times 0.33, which should work for us that 100 degrees Celsius should be 33 degrees Newton, 0 degrees Celsius should be 0 degrees Newton. And we can both define it here, and if we wanted to say print, let's make a little F string here to say that the boiling point of water in air is, and let's do our calculation, Celsius to Newton, 100 degrees Celsius, degrees Newton. So this will define our function, then we're going to use it here to convert 100 degrees Celsius and see that the boiling point of water is 33 degrees Newton. So at least it seems like our function's working properly. Hopefully you ended up with something similar to this. Any questions about defining your own function or any kind of problems that came up? All right. So another thing that's useful here to know about functions is that you can define a function that uses other functions within its own definition. So we have now a function that will allow us to convert Celsius to Fahrenheit, and a function that allows us to convert kelvins to Celsius, which means we should have the possibility to convert kelvins to Fahrenheit, because we can go from kelvins to Celsius, Celsius to Fahrenheit. So let's make a function that does that. And we can define our function called kelvins to far, again with a def statement. Kelvins to far. It's going to take temp kelvins as its parameter. And within this function definition, let's convert first from kelvins to Celsius. So we can say that our temp Celsius is going to be equal to this kelvins to Celsius function when we pass the temp kelvins value to it, like that. So we'll get our temperature converted from kelvins to Celsius first, and then we can say that our temp F, or temp far, is equal to, and then Celsius to far, and this will be then temp underscore Celsius. So we're doing this kind of in two steps. We take in our temperature in kelvins. We first use our kelvins to Celsius function that we defined earlier to convert from kelvins to degrees Celsius. Then we store that as temp Celsius. Obviously, logical choice for that name. Then we convert our value we just calculated from the kelvins in temp Celsius using our Celsius def to give us a value of the temperature in Fahrenheit, and then we can simply return our temp var. We could also return the second thing here, but since we do two conversions, I think it looks a little bit kind of easier to see what's going on in the function to put them onto separate lines and then just return the value after that. But these are both functions that we defined earlier, and we're able to use them within another function that we're creating here. So this is handy. So you run that, it will store that function in memory, which would then allow us to say absolute 0 Fahrenheit, so FAHR, is equal to, and we'll use our kelvins to var function with a value of 0 kelvins. Very much in line with what we have done earlier, we could then have a print statement. Struggling with the typing this morning. That would allow us to print out the value we get, which is to say that absolute 0 is, and then we'll put our converted value here inside curly braces. So this is absolute 0 var degrees F. This is pretty much the same template that we followed above, but now we're using our conversion from kelvins to Fahrenheit to allow us to do this. And we see that absolute 0 is minus 459.67 degrees Fahrenheit. I don't know whether that's right, but it looks like consistent with what I've seen in years past in the course. So I'm assuming that this is correct. It should be a larger negative value than Celsius would be in for absolute 0. Yeah?
We just want to think that we still need to use the X.
No, I mean, it's just like whenever you're adding the text along with some numbers, it's handy to use the F strings, but if you just want to check and see, like, first off, does this function work at all, and I don't want to bother with this F string, you could just print out the value that you calculate itself, and you'll get the number back to the screen that way. The thing that might be handy here is, like, if you've got this F string, you can see it doesn't get rounded very nicely here. So we could, for instance, add in this 0.1f formatting piece after the variable name here, which will then round the value to 1 decimal place. So if you want to have kind of nicely formatted output with the same number of values after the decimal place each time, I find that it's just almost as easy to make a print statement without an F string as it is to make one with an F string, and the F string just gives you extra flexibility. So, yeah. Okay, so let's move on to a couple other things before we're not super far into our functions lesson, and we're coming up on break time here shortly. So this is a new thing that we added to the lesson this year, or some new material that's been added to the lesson about some other variations about how we can define and use functions, because what we were finding is that the functions we learn and use in the lesson today, for instance, are very simple, and then we say, okay, now you guys can go and use these libraries where there's functions that do a lot of other more complicated things, and the step between the two was not very clear. So we wanted to cover a couple things here. We can do that somewhat quickly, and I might refer you to the lesson material for the last part of today's lesson about functions and namespaces, because we're not going to have time to do that, but that's not a big deal. But just to show a couple other variations of how functions can work, you don't necessarily need to have a return statement. It's not obligatory to have one in defining a function. So if we created a function like this one here, print kelvins to Celsius, which is already filled in the cell for you. What it does is it converts temperature from kelvins to Celsius. Seems obvious enough there, but it also then prints it out to the screen for us. So instead of having to run the function and print the value, we put the print statement inside the definition of the function. The main purpose of this function is to print something to the screen. So having a return value is not necessary here. It kind of wouldn't make sense in this case. So when we run this, and I'm just going to copy paste to save a little bit of time here. This print kelvins to Celsius with temp kelvins. Let's say temp kelvins equals 0. So we'll stick with absolute 0 here. When we run this, we get 0 kelvins is minus 273.15 degrees Celsius. That's our print text that comes from the function here. So when we run the function, we get something printed to the screen automatically. So we don't have to have a return value. If we did want to assign the output from this function, so let me just copy what's here again and say, like, make a variable called output and say output is equal to this print statement, and then I was to print the value of output. When I run this, I get the things printed to the screen from calling the function, but when I print output, I get back a value of none. If you don't have a return statement in a function, it will always give a value of none when you run the function. So if you assign the output from our function, thinking that, oh, I'll get my character string that I want to print as output, that's not how this function works. It does the printing for you, and then because it doesn't have a return statement, assigns a value of none to the value that you assign, for instance, output here. So just something to be aware of, that yes, you don't have to have a return statement, but if you don't, you get back the value of none when you try to assign the value to some variable. Now, everything we've seen so far has been a function with a single parameter, temp Celsius, temp Fahrenheit, temp kelvins, whatever. But of course, it's possible to define functions that have multiple parameters. So let's imagine a scenario here, kind of hypothetical thing. You're preparing to visit the US, one of the few countries clinging to the Fahrenheit temperature system, and you're unfamiliar with it. So you talk to a friend there, says, okay, well, 68 degrees Fahrenheit, that's a pretty comfortable temperature. And you're like, okay, that sounds fine. And normally, within plus or minus 5 degrees of whatever comfortable temperature, I'm okay. I feel comfortable like that. So what you want to do is create a function here that tells you whether a given temperature in Celsius would be within the kind of comfort range of temperatures in Fahrenheit. So what it does is our function takes a temperature in degrees Celsius as an input. Here it's called temp Celsius. Converts it to Fahrenheit, and then checks to see is it within 5 degrees of, in this case, 68 Fahrenheit, to tell you whether or not that temperature should be comfortable. And this is kind of to help you learn the Fahrenheit system as part of your hypothetical trip. And what it does at the end there is it returns a Boolean value. It says, okay, it's either true or false. You're either within the comfort range or not. So you give it a temperature of whatever, some Celsius, and it says, okay, is this within the comfort range based on your friend's idea? So we have a function here, and it's a little bit more complex than what we dealt with before. It's still got a def statement. It's still got a name, temp in comfort range. Here's our temp Celsius value that comes as an input. And then we have our ideal Fahrenheit temperature of 68 and our Fahrenheit temperature range of 5 degrees. So if we're within plus or minus 5 degrees Fahrenheit, we'll consider it to be in the comfort range. So first thing the function does is it converts Celsius to Fahrenheit like we've done before. Nothing surprising there. Then it figures out what's the minimum comfortable Fahrenheit temperature, which is just our ideal minus the range. Maximum is ideal plus the range, so plus or minus 5 degrees. And then there's a logical test here. It says the temperature is in the range if temp Fahrenheit is greater than or equal to the min and less than or equal to the max. So essentially within the range, that'll be true or false. And then we get back the true or false value as we expect from our function. So you can just run the cell and then we can see how it works. So let's take something like 21 degrees Celsius, comfortable temperature, and let's see whether that's considered comfortable in Fahrenheit in the US. So we'll say temp in comfort range, and then we give here 21 degrees Celsius. And when we run this one, we see a value of true. So 21 degrees Celsius is, it's about 70 degrees Fahrenheit, so that should be within our temperature range, 68 plus or minus 5. And indeed, that's a comfortable temperature. So we see that, yes, as expected, 21 degrees Fahrenheit is a comfortable temperature. Now you can see here we had 3 parameters that were defined in our function, but we only passed one value here. We'll come to that in just a moment. But when we have multiple parameter values in our functions, it's often the case that it can be helpful to use the function by also giving the names of those parameters. So if we put our temp and comfort range function here, we could say, for instance, our temp Fahrenheit range. And let's say, we could change this a little bit. Let's say 8 degrees, just to do something different. We could say our temp Celsius could be, let's say, 24 degrees Celsius. And then our temp far ideal, we could keep as 68 degrees. So this is more or less same kind of function call. We just increased the range of comfortable temperatures a little bit. We've given it a different temperature in Celsius, and we've given the ideal temperature as the same thing as it was before. When we run this, we also get the output that comes back saying that it's true that 24 degrees Celsius is still considered a comfortable temperature. We could, of course, make it 28 and get to the condition that it's too hot, and it's no longer considered comfortable. But 24 degrees is considered comfortable. And what you can note here is that when you name the parameters like this and give a value, they don't necessarily need to be in order. So that can be helpful. This is especially true when you're using functions that you don't have much familiarity with, that you don't know the order they were given when the function was defined. So it's nice that you can give their names and then just put them in whatever order, and Python will know what to do. So that's useful. Now, the lesson materials go into talking about required and optional parameters in a little bit more detail, and also talks about functions with multiple return values. We won't come to using functions with multiple return values right away, so I think I will skip that for now. But one thing I wanted to note is back when we defined our function here, you can see that there was something like temp Celsius that has no equal sign and a value given after it. And then there were these things like temp far ideal and temp far range that did have an equal sign and a value given after it. These are optional parameters. So when you use the function, you don't have to specify a number for temp far ideal or temp far range in order for the function to work. It will simply take these numbers and use them if you don't provide any other value. However, you'll notice here that there is no equal sign after temp Celsius, and that is because it doesn't really make sense to use this function without giving a temperature in Celsius. If your whole point is to check and see whether a temperature that's converted to Fahrenheit is within some ideal Fahrenheit temperature range, then it's kind of pointless to run this without giving a temperature to convert. So in this case, temp Celsius would be a required parameter, and the others are optional. So we saw that here, right? We ran this first case. We specified only this number, and that was what's assigned to temp Celsius. And it knows that it goes to temp Celsius because the other values are optional, and any required arguments, if you list the numbers without a name, they will be assumed to be in the order that they're defined in the function. And in Python functions, you're required to list required parameters first and optional parameters after them when creating the function. So it would be fine for us to put like 3 numbers here. This is exactly the same as what's, basically it's using the default values. You don't have to give their name, but they are then assumed to be in the order in which the function has had them defined. But if we, for instance, don't give any value, we get this type error that says that you're missing one required positional argument. So this value, temp Celsius, there has to be a number given for that value in order for the function to work. So this is described in a little bit more detail. You can see the text that's here in the notebook, but also on the lesson materials for the functions lesson, you can find more information about these required and optional parameters. And I would suggest you maybe have a look at that just to understand those things, as well as this function with multiple return values. We basically just take this function we've been working with and modify it to also return what the temperature is in Fahrenheit. So you get the true or false, am I in the comfort range, and also the temperature back. And there's just a couple examples about how to work with functions that have multiple return values after that. And I think, I'll also leave this variables inside function stuff for something you can look over in the lesson materials online on the course page, because I think we don't need to go through this in order to understand the material for this week's lesson. It's more just talking about when you define variables inside functions, they exist in a kind of independent space from the variables that are defined outside of functions. So this is why, if we wanted to, all of our functions that we defined earlier in the lesson, like when converting Celsius to Newton, Kelvins to Celsius, Fahrenheit to Celsius, whatever, they could have all used variables called temp as the parameter value, and they wouldn't conflict with one another. It's fine. Once you define something in the function, it only knows about things that are defined inside the function. So there's some discussion about that on the course page. I think that's... there's also something about documenting functions with docstrings, but we'll skip that as well because this is covered in this week's good coding practice. So are there any questions about the basic function stuff at this point? Because we are due for a break, I can see from the sort of body language. And why don't we take 10 minutes and then we'll come back and we will continue with talking about use of AI for generating Python code.